So 20 by 5. Plus something times something. Plus something times something.
So you've got 20 by 5 plus 50 by 5 plus 65 by 0.
So that is, well, what is the displacement? Sorry, what is the time in the middle bit?
In the middle bit. 30 minutes.
Yeah.
So that's 30 by 5.
So we want the average velocity. Let me think about this. Okay. And then the last bit?
20 by 0.
So it would be minus 5 because it goes this way.
Oh yeah, because it goes the other way. Yeah.
And I believe that's 15. But I think the velocity in the middle bit is 0.
Right. Yeah, because it's stationary.
Yeah, so I think it's going to be 30 for 0. Okay. No. How do you find distance? Sorry, how do you find speed?
Distance divided by time.
Yeah. So velocity is like that. Velocity is displacement over time. I'll call it D for displacement. Okay, so for the first part, what's the velocity?
5,000 over 20 if we're doing meters, but 5 over 20 for kilometers, so a quarter.
Yeah, so let's say 0.25. And then the next bit?
0 over 30, so just 0.
Yeah.
And then minus 5 over 15, so minus a third. Minus 0.3 recurring.
So minus a third, yeah. Okay. And so what do we get for that?
Minus 0.83 recurring.
So recurring kilometers per hour. I just want to see something else about this. Oh, hold on. So part A just wanted it for each stage of the journey. Okay, so that's what we did. We said it's on average, the average velocity. So this one is 0.5. That one is 0. This is minus a third. And then for the entire thing. Okay, and now they want speed. How do you find speed? Oh, hang on. They wanted per hour. This is in minutes. So it's like 0.25 per minute. So how do we get it per hour?
Multiply it by 60.
Yeah. So what do you get there?
15.
Okay.
Plus. And then minus 20.
That's going to be minus 20.
So that's minus 5.
Yeah. And so you get minus 5 out of 65, which I believe is that minus 0.83 recurring. What about part C? average speed. So it's not velocity, it's speed.
Speed. Would it just be 15 times 5?
You would, so the average speed, is total distance over total time.
Yeah, okay. So 10 kilometers over 65. And then times that by 60 for kilometers an hour.
So the total distance we could get by finding the area under it. That would give us a total distance.
Okay. So we have half 20 by 5.
Mm-hmm.
And then for the rectangle, I don't know, 30 by 5. And then half 15 by 5.
And then a half times 15 times 5. So that's a half of 75. What is that in your calculator?
37.5.
Okay. What is the total distance?
187.5. No, 237.5, sorry.
What is the total time?
65 minutes.
And so what is the average speed?
3.654.
So that's 3.654. That's kilometers. And what's the time?
Time is minutes.
And so let's do it into kilometers per hour just in case.
Sorry?
So let's turn it into kilometers per hour just in case.
So multiply by 60. 219.2 kilometers per hour. 219.2
kilometers per hour. Okay.
Yeah.
So the last one didn't say what the unit they wanted, so we just did it in both. Yeah. So average speed, total distance over total time. That's the simplest way. Let's take a look at the velocity way. So average velocity is displacement from the starting point over the time taken. Well, what is the displacement from the starting point?
Well, 0.
Yeah, I think that's just going to be 0. And so speed is a different thing. Let's see. So A, they broke it down. They got -5, minus a third. In kilometers per hour, -20. Let's see. Part B, displacement was 0. Yep. And then this one, miles per hour. Hang on. Total time is 65 minutes. The total distance traveled, they said, was 10 kilometers. Why is that? Total distance traveled was 10 kilometers. Why is the total distance 10? Hang on. So they traveled 5 kilometers.
They traveled 5 kilometers one way and then 5 kilometers on the other because it's a displacement time graph, so it's just 10 kilometers now. Unless I'm wrong.
Yeah, maybe that is it. So it's 5 away and 5 back. What am I thinking of? No, I'm thinking of the harder ones. Okay, silly me. Okay, are these worth doing? No. Yeah, see, there's not even any exam questions for those. Okay, velocity time graphs is what I'm thinking of. Velocity time graph, I think you've got a good idea for this one. So that's a velocity of 0. That's a constant velocity. That's increasing velocity. The area under the graph, velocity times time. What will that give you? Velocity times time is like speed times time.
Distance.
Yeah, distance, or if it's velocity, displacement. So this is what I'm thinking of. Yeah, it's just because I have no experience with the displacements time graph, because it just never comes up. Okay, let's try this one. Example 2.
So 6 times 8 plus half 8 times 4.
8 plus a half times 8 times 4. Looks good.
So that's 72.
72. Okay. Unit?
Meters.
Yes. B.
So that's at 4 seconds. Is it just 4 divided by 6?
Well, let's say if this was a graph, what would be this coordinate?
6, 8. 8, 6, sorry.
That'd be 8, 6. What about the ending coordinate?
0, 12. 12, not even. Oh, jeez.
Yeah. Oh, sorry. It's a weird graph. How do you find the rate of change from a graph?
y1 minus y2 minus y1 over x2 over x1. So do minus 6 over 4.
Yeah. Okay. What do you get?
Jeez. Minus 1.5.
Unit?
Meters per second to the minus 1.
Yeah. And so technically the question said the rate that they decelerate. So I suppose the rate that they decelerate is 1.5.
It's just 1.5, yeah.
But hopefully they wouldn't be too picky about that. Let's see. They got 60, not 72. Did you do something wrong up here? 6 times 8 is 48.
Yeah, probably added it wrong.
And then 4 times 4 is 16. Oh, I think you're...
Yeah.
What do you get for that one?
16, 64. Yeah, I just added it wrong.
Okay. So 64 meters. And then... Wait, they're getting 60 meters? Wait, what? After 12 seconds is given by the area under the graph. That is 6 times 8 is 48. This is 4 times 6 is 24, 12. What did I write? Why did I write 16? The difference here is 4. It's because the height is 6. It's not 8. It should be 6.
Yeah.
Which would make that 12. Okay. Which makes this 60. they did it as a trapezium, and so for this one it wouldn't make much of a difference, but for the one before it would make a big difference. Trapezium, a half A plus B H, where A and B are the two parallel sides, and H is a perpendicular height. So I think that would be the easiest way to go about these ones for the area.
Okay.
Yeah, deceleration 1.5. Any questions about that one?
No.
Okay. So we'll try this next one, and they don't give us a graph, which doesn't make it easy. Hang on, let me just see if we decide the displacement after 75 seconds. Yeah, let's do this one. So this is exam question. Take a chance. Skip to question C. Part C.
After 75 seconds. So we find the area underneath. So half 20. Unless we do it with the trapezium.
Half A plus B H.
Yeah.
So that's a half. What is A? What is B?
I think both 8.
No. They're the two parallel sides.
75 and 40.
Yeah. And perpendicular height?
That's 8.
Yeah.
Yeah.
Okay, calculator, try that.
460.
460. That's it. Well done. 460 meters. Let me just take a look. Sure. The value of the acceleration, we could. How about this question 1? What is the displacement for this one? So part B.
So half 12 times 8 in brackets times 9. So
Yeah.
that'd be 432.
32. Great. Okay. So I think, yeah, once you're good at that one, it's easier than the triangle stuff, you know.
Yeah.
Lots of triangles and stuff going on. Okay, so now, no, did that one. Now we have one with no diagram to help us. Let's try example 3.
So, I'm just finding t, right?
Okay, if you could do it without a graph.
I mean, I've sketched a graph, which I think is accurate.
Okay, and then B.
So, displacement is 600 then.
What is it?
110 over 9.
Okay, and how did you calculate it?
So, I put half a plus b by height, and that made so 40 plus 5t plus 40 times 8.
40.
40 because we have t seconds.
So what is A?
A 40 plus 5t.
What is B?
4t.
Okay, so the bottom part of the diagram is 40, so that's, let's say, B. The middle bit, remember they said the particle then travels at a constant velocity for 5t seconds.
Oh, right, yeah.
And so what would be A?
8 times 5t, so 40t.
No, it would just be the length of this line.
It'd just be 40.
It would be 5t.
Oh, yeah. Okay.
And so the little trick is that actually this part on your diagram would actually be 6t. So if they do it for t seconds and then they do another 5, that would be 6. But basically this line here is 5t.
Yeah, okay.
And so that's the equation you try to solve.
Okay. 22.
Correct. Yep. And I did some calculator stuff and I got 22 as well.
Okay, yeah.
Yeah, fine. I think you know how to calculate that. Any questions about any part of that?
So 60 at the bottom, is it because the particle accelerates uniformly for 5t?
Yeah, so what
velocity, yeah.
it wasn't very important with the 6t part. I thought it would be. But basically they say it travels at a constant velocity for 5t seconds. And so A was 5t.
Yeah, okay.
B was 40, so that's all there is to that. Not an easy one. Let's see. And so T is 10. What? The displacement is 600. 4. It's a half A plus B H, which makes a half times 8 is 4. Yes. They said 11T plus 40. Where is the diagram? That was not my understanding. Oh, okay. That was not my understanding of the question. A further 40 seconds.
Oh.
So that was not... Oh, okay. That was not my understanding. So this part of it is 40 seconds. So it's 40 seconds plus...
Plus 60.
Plus the rest of it. Okay. So
okay.
Further. All right. We just need to read the question. Let's see. So we did this one. So you're good for acceleration and deceleration. We did the displacement thing. I think you're good for that. Let me just see. This looks like the one to try. Question 7. The value of u and the acceleration for the first 3. Yeah. This looks like the one to try. And it's not easy. And I think this is the last one we'll do of this type, and then we'll move on. Okay, how about this?
To try to find total displacement and then from that work out u?
Yeah.
Okay, so displacement is 95 meters.
For how did you get that?
Half 7 plus 12 times 10.
A half 7. Oh, I see what you're saying. Plus 12. That won't work because this shape isn't a trapezium, because this line here would have to go down to the bottom again.
Oh, okay.
So what you can do is find the trapezium from 3 seconds onwards. So I'd find that area first.
Okay. So So 80.
Okay, so this displacement is 80 in here.
Mm.
And so what displacement must this be?
15.
What was the total displacement in the question?
Oh, 100 meters. So 20.
So this one in here must be 20. And so how can you use that to work out U?
Half A plus B equals 20. Times
Yeah.
equals 20, yeah. So
And okay, what is A, what is B, what is height?
So A would be U and B would be 10.
2 parallel sides.
Yeah.
So A is U. What side is parallel to U?
10. So
10 is,
the height
10 is
on
perpendicular.
Wait. Is it? Hang on. No, because wouldn't you have to flip it on its side since we're only looking at that segment?
Yeah, we'd have to flip it on its side. So
Yeah.
what side is parallel to the U?
So the height originally. So 10.
Sorry, it is 10. What am I thinking? 10.
And then multiply by 3.
That's it.
Equals 20.
That's it.
That's it. Minus 20 over 3.
So I'm getting something similar with a negative.
Yeah.
Let's just think about this. So it's a half A plus B H. So this line is definitely 10. This line is definitely 3. This is u. This is our unknown. And so it's a half u plus 10 times by height. So you get 20 over 3. Then you get 20 over 6. And then that's it. So we want, oh, of course. Hang on, the acceleration of the particle. Oh, hold on. Yeah. Hang on, is that what they asked us for? What's the acceleration? No, that's okay. Half a is u. V is that. Okay, so what would you do with your answer then?
What did I get?
Yeah.
20 over 3.
Okay, yeah, so you would just make it positive.
Yeah.
That's it. Okay, any questions about that?
No.
Okay, that's fine. And so that's the last exam question for that. So what would you give yourself for the graphs, x a half or tick?
Yeah, I mean, I'd probably have to revise a bit more, but right now it's a half, I guess.
Okay, it could be there or something.
Yeah.
3/4. Okay, constant acceleration formulae. You've got all sorts of formulae, and you have to use them all. Do they give them to me in some easy format? No, they give them to me all mixed up. We'll see if you know them. If not, we'll have to do it. Okay, how about this one? Example 4.
So velocity times time would equal distance. But then there's the acceleration.
And so perhaps let's just bring these in. So we've got that one.
Yeah, SUVAT. Okay.
We've got a. Oh, did I make a new page? Okay. So we have to find the distance. So you have to pick a distance formula.
So we'd use S equals UV over 2 by T. Initial velocity.
And that's just another way of writing a half a plus bh.
Yeah. So we have 4 plus 5 over 2. 4 plus 7.5 over 2. By 40. That gives us 230.
230.
And that being meters, yeah.
And B.
Acceleration. So V equals U plus AT. 7.5 equals 4 plus 40A. So then we make A the subject.
Mm-hmm.
Divided by take away this 3.5 equals 40A, and then 3.5 over 40 will equal acceleration. Zero point 0.0875.
0.0875. Unit for this one?
Meters per second minus 2.
Yeah, because it's acceleration. So we 230 and 0.0875. 230 and 0.0875. Great. Velocity and distance. Okay, let's try this. And I'll just grab that previous formulae.
Okay. So we'd use V equals UAT, U plus AT for the first one.
Okay.
So that'd be 2 equals 8 plus minus 1.5 T. So T into the subject.
And what were the values for A, U, and V?
A is minus 1.5.
Mm-hmm.
U is 8.
Mm-hmm.
And then V is 2.
Yeah, that's fine. Okay, go on. You can try to work it out.
Yeah, minus 6 equals 50. T equals minus 4.
Minus 4 seconds.
Yeah.
4 seconds.
Yeah, 4 seconds.
And it would be V minus U, so it would be 2 minus 8 on top.
Yeah.
Part B.
distance. S equals 8 plus 2 divided by 2 by 4. So 5 times 4, yeah, it's 20 meters.
Yeah. And part C.
See. So V equals, V equals U plus A2.
Mm-hmm.
We'll be trying to find V, so 8 plus minus 1.5 times 4.
Wasn't it 4 seconds to get from A to B?
6 seconds, yeah, sorry. So V equals minus 1.
Yeah, nothing wrong with negative velocity.
Yeah.
That just means it's going back in the other direction.
It's, the other way. A to C. So S equals 8 plus a minus 1 over 2 by 6. So 3.5 times 6. 21.
Yeah, I think that's the displacement. But they asked for distance. And so if that goes back, then there's something more to this. So the current continues on a straight line with constant acceleration. When would it have, what would be the displacement when it reaches a velocity of 0?
So 0 equals S equals 8 plus 0 over 2 by, we wouldn't know the time, would we?
Let's see. Okay. So let me just see. So you have A, B, and C. So A,
T.
B, C. So from A to B, the time is 4 seconds.
Yeah.
And then from A to C.
A to C, it's going to be 6.
And so B to C is 2 seconds.
2, yeah.
So the speed at A is 8. The speed at B is 2.
Speed at C is minus 1.
Speed at C is minus 1. How is the speed at C minus 1? Yeah, I would have to, but hang on. Is that the point C? Okay. No, that's fine. That's fine. So we now have to find. So it kind of went the distance from A to C. So no, that might be fine. That might be fine. Is it 21? Let's take a look before I do anything crazy. So time is 4. Fine. The distance from A to B is 20. That's fine. We said minus 1. That's fine. And then this last one is 21. That's fine. Don't listen to me.
Okay.
So let's see. So there was one thing. There's an exam question. Ski traveling. Let's just give the exam question a quick go.
Alright.
Okay, let's try this. Oh, it's not easy. Hope we're not skipping too much.
So choose V equals U plus AT. V equals 0, U equals 16 plus A and 40A. So equals minus 16. I've got minus 0.4
Okay.
meters per second by minus 2.
By minus 2?
Um,
oh, meters per second. Yeah.
Yeah, to the power of.
Okay, part B.
B. Down. S equals 8 times 40, so 320 meters.
2, and let's take a look. B, the distance. So let's see. So we know that U is 16, B is 0, time is 40. We now also have that A is minus 0.4, and we just need the distance, so we just use the easiest one. The distance from the bottom of the hill to the point where the skier comes to rest. S is equal to 16 plus 0 over 2 times 40.
40.
And what was your answer?
320.
That's it. Hello, 4 marks. I'll take them. Skier
Pretty easy
showing
for maths.
constant deceleration. At the bottom of the hill, skier has a constant velocity of 16. Moving up the hill 40 seconds, he comes to rest 20 seconds. The distance from the bottom to the point where... That's it. This is 420. So that is kind of those two formula out of SUVAT. What would you give yourself? X half or tick?
A tick, I guess, yeah. Pretty confident on that.
Yeah. So, how was that for you, Mieszko?
That was good, yeah.
So
that helps a lot.
If you like, we can finish SUVAT next time or something else. We could
probably be fine with the other equations, but some of the more complex SUVAT.
Okay. Complicated SUVAT. And then the Newton's law stuff, if you want.
Yeah, that would be good.
Okay. Any questions for me in general?
There is a lesson next week, yeah.
Yeah.
Yeah, okay.
Any other questions?
No.
Okay.
I think I'm good, yeah.
Well done. Mieszko, you did great.
Thank you.
I look forward to chatting again next week.
Yeah.
All right, have a good week.